Hello. In this video, let us sketch a graph of a cubic polynomial. So sketch means to make a picture by hand, and this is a cubic. So we are expecting that one arm is going to go up, one is going to go down. Now, when we are making a sketch, we need to provide a few key pieces of information. One of them is the intersects. So to find the y-intersect, the place where this curve is crossing the y, we make x equals 0. If we put 0 for all of these x's here, the only thing left will be 3. So this means y is 0 cubed minus 0 squared, 3 times 0 plus 3, which is 3. So the y-intersect is 3. The x-intersect is found by making y equal to 0. So if we make the left side equals 0, what kind of equation do we get? Well, there is 0 is x cubed minus x squared minus 3x plus 3. Now, if we had a quadratic equation instead, then any quadratic can be solved with a quadratic formula. But for the cubic, we do not have such an easy formula to use. So instead, for anything that is more than a square, what we use is we use fundamental theorem of algebra to tell us how many solutions we get. And fundamental theorem of algebra tells us that we are going to get 3 solutions because the degree is equal to 3. So fundamental theorem of algebra, fundamental theorem of algebra promises us 3 solutions. And these solutions are going to be 3 solutions if we count repeats and if we count the imaginary solutions. So looking at the diagram, let's actual curve, let's make a picture for it and have a look. So here is the original. It is x to the power 3, and then minus x to the 2, and then minus 3x, and plus 3. So let's have a look at the picture. That's a standard window from minus 10 to 10, and the goal is to find some places where the graph crosses exactly, so we can use this point to do synthetic division. And it looks like maybe 1 is actually a good guess. So let's check it with the calculator. Calculate and go to the 0. And let's see if this first positive, if it actually is a 1 or not. So here, mark and guess in the middle. Yes, the calculator says that it thinks its guess is that 1 is actually a solution, it is an intersect. So let's use that in synthetic division. So the calculator says x is 1. Now, using synthetic division, we're only using the coefficients of our polynomial, which is 1, -1, -3, and +3. We make sure that all the terms are present, and if anything is missing, we put 0 in its place. And then we divide. So first is we add down, and then we multiply diagonally. So 1 plus nothing is 1, and then multiplying diagonally, 1 times 1 is 1. -1 plus 1 is 0. 1 times 0 makes 0. -3 plus 0 is -3. -3 times 1 is -3, 0. And that last number is remainder. And since remainder is 0, that proves that x equals 1 is actually a solution, is actually one of the 3 intersects, 3 solutions that we were promised by the fundamental theorem of algebra. But where are the other 2? Well, the other 2 are located in this polynomial. We started with a cubic and we divided by 1x. So all of these powers are now 1 less. So these are the numbers that go with one power less than what we started with, meaning this is really 1x to the 2 plus 0x minus 3. So the other two solutions are found here in this quadratic, because it is the highest power is 2, and this will have two solutions using the same fundamental theorem of algebra. Now, these could be found using quadratic formula if we wanted to. It is missing one of the terms, the b is missing, so it doesn't actually need a quadratic formula. All we have to do is undo the remaining operations and get to the x. So if we add 3 to both sides, we'll get x squared equal to 3, and to cancel the square we use square root. And each time we use square root we have plus minus in front of it, so we have two more solutions, plus square root of 3 and minus square root of 3. So according to our fundamental theorem of algebra, there was 3 answers, and here they are: 1 plus square root of 3 and minus square root of 3. To make a sketch, all we need to do is put this information on the graph. We already saw the picture with a calculator, so let's reproduce the same on our work and label all the key information. So here is the x-axis, the y-axis. We have, now the square root of 3 is a decimal, and here is, let's find what that is. Calculate second 0. So let's get to the next positive. And this number is 1.733. It never actually ends. It is irrational. It cannot be written as a fraction. It will be a decimal that goes on forever. And the only way to find it is exactly is by doing the work by hand, which would be either using a quadratic formula or the way we just did it, taking square roots. So on the graph we can now mark. So let's say this is 1, this is 2, this is -1, this is -2. So the graph is going to go through 1, that's one of our intersects, and then 1.7 is about here, that's a positive square root of 3, and then on the other side is negative square root of 3, which is -1.7, and then the picture goes through y equals 3. So there is 1, 2, 3, so y equals 3, that's our first intersect that we found, and so here it is. So the picture will come up from the bottom, cross our first intersect, then cross our second intersect, and head back up. So this is what the sketch looks like with everything labeled, and it is similar to what the calculator showed. So this picture with the calculator confirms that what we did by hand actually is correct. The only thing that we needed to do is provide the exact values, square roots, which can only be found by hand. And the rest of the work, most of it can be done with the aid of the calculator. And that's all for this video. That's why it's important to have these components. It's important to know the fundamental theorem of algebra, because then we would know how many solutions to expect. If some solutions are imaginary, they will not show up at all on this intersect. If some solutions are not rational, we will not be able to write them as a fraction, and they will not show up in rational zero theorem, because rational zero theorem cannot find irrational solution. It can only find rational solutions. So these numbers could only come from the way that we did it. And that's why it's important to have all of these components present, because sometimes on the test, the homework, these types of examples do show up. And that's all there is for this video. Thanks a lot for your time.